Dear friends, in this video we are going to discuss about pollution control technologies, namely gaseous emission, that is by means of removal of sulfur dioxide, particulate emission by using wet scrubbers, electrostatic precipitator, backwash filters. So most of the power plants today we are using, that is 70% of the power plant, so power generation is from coal-based power plant. So coal-based power plant where we have huge amount of fly ash, that is the pollution coming out from thermal power plant. Because of burning coal, by burning the coal we are getting more amount of fly ash, particulate matter, smoke, everything. So we have to filter before letting out to the atmosphere. That is the aim of this methodology, pollution control. The common methodology used in major power plants for pollution control is electrostatic precipitator, which controls nearly 99% of the pollution, but it is not suitable for high resistive fly ash. For that, in that case, we have to again, after going through the electrostatic precipitator, we have to make this to go to the wet scrubbers also. But most of the fly ash will be filtered by using electrostatic precipitator. This is a simple device which will be fitted under the ground. The exhaust gas from the power plant will be allowed to pass through this electrostatic precipitator at one end, and on the another end the purified exhaust gas will be coming out. That will be allowed to enter the stack or chimney, then it will be returned to the atmosphere. In this video we will look about the working concept of electrostatic precipitator, and here we can note that this electrostatic precipitator is being manufactured in Bharat Heavy Electricals Limited at Ranipet, Bharat Auxiliary Plant, BAP plant at Ranipet. There they are manufacturing this type of electrostatic precipitator, and it is being used in Indian power plants as well as in abroad. They are exporting this electrostatic precipitator. The simple mechanism, easy to understand and easy to construct, easy maintenance also. Solid or liquid particles in the effluent gas can pick up a charge and be trapped in an electrically charged filtering device. That is the basic mechanism of electrostatic precipitator. If you look at this diagram, you can easily understand that it consists of two sets of electrodes. One is a positive, another one is a negative electrode. The positive electrodes are of plate shape. They are made of plates, whereas the negative electrodes are in the form of wire mesh. These two electrodes, positive and negative electrodes, are placed and are alternate to each other. First they will place positive, negative, positive, negative, positive, negative. In between, the medium will be there. Here we are using air as the medium. The negative terminal of the high voltage DC, that is nearly, we are using 30,000 volt, 30,000 volt to 60,000 volt. Very high voltage DC is used to connect the negative electrodes and positive electrodes. So the high DC voltage is there, that is 30 to 60,000 volt. The important one is we have to understand here. If you look at this diagram also, we can have more idea. See, if you look at this, yeah, the positive electrode is in the form of a plate, whereas a negative electrode in the form of wire mesh. These things will be kept alternately. These two are connected with high voltage DC, that is nearly 30 to 60,000 voltage. The medium in between these two is air, that is between negative and positive electrode is air. To ionize the medium between the negative and positive electrode, a certain distance is maintained, and DC source result in high voltage gradient. There might be electric discharge around the electrode rods or wire mesh due to high negativity of negative charges. This entire system is kept in a closed metallic container containing an inlet for flow gases and an outlet for filtered gases. Here we have to note one point, that there are plenty of free electrons as the electrodes are ionized, which interact with the dust particles of the gas, making them negative charge. This is the basic concept, which is a important point we have to understand, that free electrons are many in between these two positive and negative electrodes. They are ionized, which are interacting with the dust particles coming out from the exhaust gas and making the exhaust gas, dust gases, into negative charge. That point you have to understand. What is free electrons? Electrons in the outermost shell of an atom, which can easily leave the atom and become free, which are called as free electrons. The free electrons are formed with low kinetic energy and they simply diffuse through the gas, taking part in the random thermal motion of all the atoms. There is the thing about free electrons. The free electrons are ionized, which interact with the dust particles and make the dust particles a negative charge. These negative charged dust particles, where it will move? The negative charged dust particles will be attracted by positive electrodes. Here the positive electrode is made up of a plate-like structure, not a wire mesh. So all the negative charged dust particles will become ionized because of this air medium, because of free electrons, and become negatively charged. These negatively charged dust particles will be attracted by positively charged plate electrode. So all the negative charged dust particles will be deposited over the positive charged plate. If you look at the diagram, you can easily understand. This positive charge will collect all the dust particles and it will fall due to gravitational force. Automatically this will be falling down, or we can shake this positive electrode plate so that the dust particles will be collected in the hopper. We can easily remove that. Then it will go a series of positive negative electrons, and it will leave the electrostatic precipitator. That is, a filtered gas will be leaving the electrostatic precipitator. If you look at this diagram, yes, you will get more idea about this. These electrodes, see, the gases are coming in, the negative charged dust particles are attracted by positively charged plate. This plate is called positive charge. Let me use this highlighter. This is positive charged plate. Here we have negative charge. Here we are getting the clean gas out. If you look at this diagram, so this is the overall view of the electrostatic precipitator. How the electrostatic precipitator will look. Here we have the collection plate, that is positive electrodes. Here we have the electrodes, alternating electrodes. Here inlet gas filter. Here inlet gas distribution system. This is gas inlet. Here the gas outlet. Here we are supplying the high voltage to the terminals of positive and negative electrodes. So because of the ionization, free electrons are formed. The free electrons are making the dust particles to become negative charge. The negative charge dust particles will be attracted by positive charge plate. There it will get deposited, and by gravitational force it will fall down, or we can move the plates so that we can shake the plates so that the dust particles will be filtered in the hooper. This is called hooper. Through the hooper it will collect and will be removing the dust particles. So this is about working of electrostatic precipitator. It is mainly used in almost in all the power plants, big power plants. And thank you for watching this video.